If you own a late model GM, Toyota, Honda, or Hyundai, there is a real reason so many of these engines are grenading, and it is not bad luck. Right now, more than 5 million engines across those four names are dying. Some are catching fire with families sitting inside. $70,000 trucks are going dead at 30,000 miles. 42 fires, 12 injuries, and the folks who built these motors know exactly what is going on, and they would rather you didn't. Let me give you the numbers, because they tell the story before I say a word. General Motors recalled 720,000 vehicles over the 6.2-liter V8, with another 280,000 under federal investigation. More than 28,000 complaints. Over 14,000 of those ended in complete engine failure. 12 injuries, 42 actual underhood fires on Silverados, Tahoes, Yukons, and Escalades. Toyota recalled 102,000 twin-turbo V6 engines in 2024, then recalled more in late 2025, including brand-new Tundras, $90,000 Lexus LX 600S, and Sequoias, with hybrids still under the microscope. Honda recalled 250,000 of its 3.5-liter V6 for rod-bearing destruction, metal shrapnel tearing the motor apart at thousands of RPM, plus a federal probe into 1.4 million Hondas going back to 2016. Hyundai and Kia recalled 1.5 million engines since 2017. And here is the kicker: some of the replacement engines failed the exact same way. Add it all up, more than 5 million engines, nearly $8 billion in damages. That is not a bad batch. That is not one clumsy supplier having a rough Monday. When one company fumbles a single engine family, you can chalk it up to bad luck. When 4 separate companies, building 4 separate engines on 4 separate assembly lines, all start blowing up motors the same way in the same window of time, that is not luck, that is a pattern, and a pattern always has a cause. I have spent 50 years chasing causes with a flashlight and a pry bar, and I promise you, engines do not die for no reason. Something specific killed every one of them, and I am going to show you what. My name is Ray Donnelly, and for 50 years I have turned wrenches on every kind of car there is, watching honest people get talked into repairs they never needed. So if that is the sort of thing you want more of, consider subscribing. It's free, and you can always change your mind later. Now stick with me, because once you see what is actually killing these engines, you will never look at a shiny new window sticker the same way again. In December of 2025, Automotive News put out an investigation, and it was a good one, the kind of digging that takes months and ruffles feathers in Detroit. They sat down with university engine researchers, the folks who study this metal for a living. They talked to independent mechanics who have personally torn down hundreds of these failed motors with their own 2 hands and laid the guts out on a bench. And they got insiders, people inside the industry, to talk, but only if you promised not to use their names, because saying this out loud can cost a person their job. What they found is simple to say and hard to swallow. Modern engines are being pushed far past what they were ever designed to survive, all in the chase for record horsepower per liter and a passing grade on a government fuel test. Every bit of what follows traces back to that one sentence, so hang on to it. Let me put that in plain terms. Back in the 1990s, a 6.0-liter V8 made about 360 horsepower. That is 60 horsepower per liter, and it would run 300,000 miles without complaining because it was a big lazy motor that never had to strain. It had metal to spare. Today, Ford's 2.7 EcoBoost makes 325 horsepower out of a motor half that size. That is 120 horsepower per liter. The 3.5 EcoBoost in the Raptor is up near 128 per liter. Double the power density, half the metal to handle it. You are asking a smaller casting to do twice the work and take twice the heat, and metal has opinions about that. Every time you double what a part has to carry while cutting the part in half, you are cashing a check the engine cannot always cover. It might cover it for 30,000 miles, it might cover it for 60, but the bill comes due, and it comes due on your driveway, not theirs. To hit EPA and CAFE fuel targets, the manufacturers went to ultra-thin oils. The 5W30 and 10W40 your dad used became 0W20, then 0W16, and now some call for 0W8, which is barely thicker than water. Why thinner? Because thin oil has less drag, and less drag means the engine spins a hair easier and squeaks out a fraction of a mile per gallon on the government test. That is the whole reason. But oil is not just there to reduce drag. Oil is the only thing keeping steel from touching steel inside your motor, and oil that thin only works if the clearances inside the engine are measured in microns, tighter than a human hair is wide. Professor Greg Davis at the University of Michigan Flint put it plainly. Higher pressures create greater bearing loads, and greater loads bring accelerated wear. Read that again. You are running a tighter, hotter, harder working engine on a thinner cushion of oil and asking it to last a couple 100,000 miles. Something has to give, and it is not going to be the laws of physics. Now here is the part most folks never hear about, and it is the invisible killer. It is called swarf. Dave of Dave's Auto Center, a master engine builder, quoted in that same automotive news piece, explains it better than anybody. Swarf is the microscopic metal debris left behind when an engine block is machined. The big chips are easy, you can see them, you can wash them out. It is the ultrafine dust from honing the cylinder walls that will kill you. Dave calls the slurry of metal dust, grit, and coolant concrete. It is brittle, it is razor sharp, it is harder than the bearings themselves, and it clings to every surface inside that block. Think about what one microscopic piece of that does. Get it caught between a bearing and the crankshaft, and at thousands of RPM, it acts like sandpaper. It embeds itself in the soft bearing material and grinds away at the hardened crank. You get scoring in minutes, metal on metal in hours. Total failure in days. And here is the cruel part. That damage starts the very first time the engine runs, right there at the factory, before you have even seen the truck. It just takes a while to show itself. The bearing wears a little wider, the oil pressure drops a little lower, and one ordinary morning you turn the key and hear a knock that was decades in the making, but only weeks in the finishing. Dave's crew cleans every engine they build by hand. Hot tanks, pressure washing, compressed air, scrubbing each oil passage 5 or 6 times before they trust it. But GM builds 10,000 engines a day at a single factory. Hand-built perfection at that scale is not possible, so the automakers lean on automated rinses and a quick visual check, and they push it out the door. Tom Howell, a powertrain tester in the investigation, added the last piece. Thinner oils, tighter tolerances, and harder bearing materials all pile up together. Harder bearings mean less forgiveness. A soft old-school bearing could swallow a bit of debris and keep going. A hard modern one just gets ground up alongside the crank. So that is the foundation. Now let me walk you through the perfect storm, because it took 6 things happening at once to turn a design compromise into a 5 million engine disaster. The first is start-stop technology. Every single time the engine shuts off at a light and fires back up, oil pressure drops to 0 for an instant, and the parts spin for a moment with no fresh oil between them. With thick oil, a film clings to the parts and holds on through that moment. With thin oil, that protective film is next to nothing, and cold starts already cause most of the wear an engine ever sees in its whole life. Now here is the math that will turn your stomach. Drivers are doing 40 to 50 of those start cycles on a single commute. Your grandfather started his truck once in the morning and once after work. This system is doing it 50 times before lunch, and each one takes a tiny bite out of the bearings. The second is variable displacement oil pumps. These are computer-controlled pumps that can lag right after a start-stop cycle, or flat out miscalculate and starve the bearings of oil at the worst possible moment. The third is extreme turbocharging. We are talking cylinder pressures over 2,000 psi, with turbos spinning between 150,000 and 200,000 RPM. At those speeds, any contamination destroys the turbo bearings and fires shrapnel straight through the rest of the engine. The fourth factor is direct injection. Fuel gets sprayed straight into the cylinder at 2,000 to 3,000 psi. Higher pressures, more stress on the fuel system, and here is a side effect most folks miss. In an old engine, fuel washed over the back of the intake valves and kept them clean every second the motor ran. Direct injection skips the valves entirely, so no fuel washes them anymore, and you get carbon buildup caking on, hotter running temperatures, and a thinner oil film right where you need it most. The fifth is the one nobody at these companies wants to talk about, and that is COVID-era manufacturing, roughly 2020 through 2022. Picture it. Chaotic factories running short-handed, brand new suppliers nobody had time to properly vet, and the quality inspectors, the very people whose whole job is catching a bad part, sent home. That is exactly when GM shipped out-of-spec connecting rods. That is when Toyota had contamination slip through. That is when Stellantis, and yes it is Stellantis, not whatever your captions are spelling it, had casting sand trapped inside finished engine blocks. All of that trouble was built into engines 4 and 5 years ago, and it is surfacing right now, at 60 to 100,000 miles, right about the time the warranty runs out. Funny how that works. The sixth factor is cylinder deactivation, where the computer shuts down half the cylinders under light load to save fuel, turning a V8 into a V4 on the fly. Sounds clever, but it creates uneven temperatures across the block, uneven expansion of the metal, and hard shock loads slamming through those dead cylinders every time they wake back up. Any one of those things by itself, a well-built engine might shrug off and live a long life. But you do not get them one at a time. You get all six stacked on top of thin oil and tolerances squeezed to the limit, all in the same motor, all fighting the same bearings at the same moment. That is the perfect storm, and you get exactly what we are seeing, 5 million times over. Now let me tell you about the cover-up, because this is where it stops being an accident. There is an independent builder named Eric Berg who spent 3 years trying to get his hands on a single failed Toyota twin-turbo V6. 3 years. Every time one of these motors blew, Toyota bought it back as a core exchange, paying to keep those engines out of independent shops and off of YouTube where somebody like Eric could tear one down on camera. He finally got one, and what he found was the whole ballgame. The main bearings, the big ones that hold the crankshaft in place, were destroyed. Scored, heat-burned, chewed to pieces, but the rod bearings, fed by the very same oil circuit, were pristine, perfect. Sit with that for a second, because this is the tell that changes everything. If debris or contamination were the cause, both sets of bearings would show damage, because they drink from the same oil out of the same passages. Dirt does not read a map and decide to only chew up the main bearings while politely skipping the rods. Dirt hits everything downstream, so the only mains failing, while the rods stay clean, points at one thing and one thing only: a design flaw. Maybe the oil passages feeding the mains are too small to keep them fed under load. Maybe the clearances there are too tight for the oil to squeeze through. Maybe the bearing material simply cannot carry the load it is being asked to carry in that spot. And a design flaw is a whole lot more expensive to admit than a little dirt, because dirt is a cleaning problem you fix on the line for pennies, and design is a tear it all down, recall the whole line, admit it in court problem that costs billions. Now you understand why they would rather blame dirt. We have seen this exact movie before, and the ending does not change. Remember Hyundai's Theta engine disaster? They blamed debris, they stood up and said it was contamination, recalled 1.5 million engines, and swapped them out for fresh ones. And the replacement engines, the brand new clean ones, failed the same way. Think about that. You cannot blame factory dirt on an engine and then watch a clean replacement die identically. Dirt does not repeat itself on a fresh motor. That is design, plain and simple, and they knew it. And GM handed us the clearest tell of all, the one you do not even need a lab to read. Their own fix for the 6.2 switches, the recommended oil from 0W20 to 0W40, that is twice as thick, twice. Now you ask yourself the simplest question in the world. If thin oil was never the problem, why on God's green earth is thicker oil suddenly the solution? They are telling on themselves right there in the service bulletin, if you know how to read it. So why would smart engineers build engines this way on purpose? They didn't, not really. The real villain in this whole story is a set of rules called CAFE, Corporate Average Fuel Economy. Those targets have climbed to a place that is simply not realistic. They rose about 8% a year from 2024 to 2026, then 10% in 2026, pushing toward a mandated fleet average near 49 miles per gallon. Meanwhile, a real F-150 gets around 20. A Tahoe gets about 18. A Corvette gets around 16. The math does not come close to working. And the penalties have teeth. It is $17 per vehicle for every 1/10 of a mile per gallon a company falls short of its target. That sounds small until you do the multiplication. Miss the target by a single mile per gallon across 2 million vehicles, and that is $340 million gone in one model year. So the companies claw back every fraction of an MPG they possibly can. Tiny turbos instead of big honest engines, thin oil instead of thick, tolerances squeezed down to the ragged edge, start-stop, cylinder deactivation. Every one of those tricks buys back a sliver of a mile per gallon, and every one of those tricks is exactly what is killing the bearings. The engineers did not forget how to build a reliable motor. Those same companies built engines in the 1990s that ran forever. Regulatory pressure shoved the designs past the point where they stay reliable at mass production scale, and the engineers were handed a target and told to hit it or else. And somewhere in a quiet boardroom, well away from the shop floor, the accountants ran the numbers and decided that a predictable rate of engine failures, paid out in warranty claims, is cheaper than missing CAFE and eating the government fines. Let that land. They chose the failures, on purpose, with their eyes wide open, and with your money. And I hate to tell you, but it is about to get worse. The 2025 rollback pulled electric vehicles out of the fleet average calculation. Before that, EVs counted as something like 200 to 300 miles per gallon equivalent, and those huge numbers offset the gas guzzlers and dragged the whole fleet average up. A company could even buy EV credits from Tesla to cover its gas burners. Now the EVs no longer count toward that average, but the fuel economy requirement is still standing, rolled back to around 34 mpg by 2031, and the automakers have to hit it without any EV help. That leaves them 3 roads, and I want you to notice that all 3 are bad for you, the person writing the check. Road 1, they go even smaller, even thinner oil, even tighter tolerances, which means more of the exact failures we just spent this whole time talking about. Road 2, big cuts in power, an F-150 dropping from 400 horsepower down to maybe 250. A Silverado rated to tow 5,000 pounds instead of 13,000. A truck that can barely do truck things. Road 3, hybrids on everything that moves, which sounds fine until you count the cost, more components to break, higher sticker prices out the door, and battery degradation that guts your resale value the day the warranty ends. Pick your poison. There is not a good option in the bunch, and not one of them puts a durable, honest motor back in your driveway. So let me get practical, because you did not come here to feel helpless. There are things you can do right now to protect yourself and your wallet. Start by going to NHTSA, and running your VIN through the recall lookup tool tonight, and if a recall comes up, schedule that repair immediately, because it is free and it is on them. Next, cut your oil change interval in half. 5,000 miles is the ceiling now, and if you tow or drive hard or sit in traffic, make it 3,500. Use a quality oil, Mobil 1, Pennzoil Platinum, Valvoline Castrol in the correct spec your manual calls for, like Dexos 1 Gen 3 on the GM stuff. Then get in the habit of shutting off that start-stop system every single time you drive, and if it keeps resetting itself, a $50 to $100 OBD2 device can make the shut-off permanent. Here is one more that will raise some eyebrows down at the dealer. Once you are out of warranty, and only once you are out of warranty, think about running 1 grade thicker oil. Just 1 grade. 0W20 instead of 0W16, or 5W30 instead of 0W40. Not 3 grades. Do not go crazy on me. Just one step up and you buy yourself a slightly thicker cushion right where these engines are starving to death. GM basically admitted this was the move when they thickened up their own factory spec, so you are not doing anything reckless, you are doing what they did, a little early. Keep your ears open too, listen for any new ticking, knocking, or rattling that was not there before. Check your oil level every 1,000 miles and watch for low oil pressure at a warm idle, because that is the early warning. And be smart when you buy used. Steer clear of first-year redesigns and steer clear of the 2021 through 2024 model years where all this COVID-era trouble is baked in. Believe it or not, a proven 2015 to 2019 naturally aspirated V8 with 100,000 miles on it may be a safer bet than a 2023 turbo with 30,000. And if you are buying newer anyway, look hard at a comprehensive extended warranty, one that specifically spells out coverage for bearing failures, because that is the exact part that is dying. Let me leave you with the bottom line, and I want you to hear it clean, the way I would tell you across the counter with the hood still up. Over 5 million engines are failing, right now, across 4 of the biggest names in the business. They are not failing because the engineers suddenly got dumb, because those same engineers built bulletproof motors 30 years ago, and they are sure not failing because you did anything wrong. They are failing because the manufacturers sat down and made a choice, and that choice was to put EPA and CAFE compliance ahead of your engine's survival. They ran the odds like a casino. They calculated exactly how many engines would grenade and decided the warranty payouts were cheaper than the fines. They did it with their eyes wide open, and they did it with your money and your safety on the table. That is the real cause, no mystery to it. So do not let a slick salesman or a shrugging service writer tell you it was just bad luck. Check that VIN tonight, change that oil early and often, listen to your engine, and buy with your head instead of the shine on the paint. Take care of the machine, because these days, nobody up top is going to do it for you. This is Ray Donnelly, and I will see you in the next one.